Hello, graders, whoever's watching this video. Today I'm going to be doing the week 4 interview question, which is talking about how we can use linked lists with stacks and queues. So for the first part, it's about using a stack or having a stack with a linked list. And to start, I want to say that the time complexity for each method that I'm going to mention is O of 1, because there's no loops. There's no nested loops or anything to make it take longer, so everything's O of 1. Stacks are last in, first out. So to implement a stack with a linked list, I would use a singly linked list. Treat the head of the list as the top of the stack. So to push, you would create your new node. You would insert it at the head of the linked list, and the new node's next points to the old head. So then you would update the head. And that works because the most recent thing is always on top. And then to pop, you remove the node at the head of the list and update the head, the next node. That always works because the head is always at the top of the stack. So the next method for getting the top, you just return the value stored in the head node without removing it. Simple. And then as empty, you just check if head is null. Very difficult there. So now for the queue, queues are first in, first out. Implement the queue efficiently, you would use a linked list with a head and tail pointer. Head represents the front and tail represents the back. So to enqueue something, you would add a new node to the tail of the linked list and update the tail pointer. It's pretty simple. I mean, I imagine it like you're using a rope to pull yourself across something. You gotta just add more to the end of it. That's also one to dequeue. You just remove the head and change the pointers after that. To get the size, you would keep a counter that increments as the queue grows and shrinks. And then as empty, you would just check if the size is 0 or if head is null. So using linked lists for both queues and stacks is good. I think it's efficient. And yeah, the operation time, or the big O for all of these operations, is O1.